Hello guys, what's up? I'm Engineer AK and today is the 8th lecture of chapter 2 Metal Structure and Crystallization. In today's lecture we are going to find the packing factor of hexagonal closed pack structure. Right now you all know that what is packing factor. In previous lecture we did that. The packing factor is actually like how the atoms are packed in its unit cell, right? So now let's start. So in packing factor we know that the formula for packing factor is the volume of the sphere divided by volume of the cell, right? It is written over here. So now first let's find the volume of the sphere. So if we find the volume of the sphere, so we know that the volume of the sphere has a formula of 4 by 3 pi r cube, right? And in previous lecture we also find the total number of unit cells. The total number of atom in a unit cell of HCP is 6, right? So mean that if we multiply 6 by 4 by 3 pi r cube, so we will get the volume of the sphere, right? The total volume of the sphere that is in the unit cell of HCP. So here it's the volume of the sphere, 6 multiply 4 by 3 pi r cube, right? Now the second, we have to find the volume of the cell, right? What is the volume of the cell? So if we see in this diagram, so here it is an equilateral triangle, right? This is an equilateral triangle, this is the another equilateral triangle, the third equilateral triangle, fourth equilateral triangle, 5, and this is the 6. So if I find the total area of this hexagon, right, and then I multiply this with this height, so I will get the total volume of this unit, right? So here I have written that the area of the equilateral triangle, right, and I have told you that there are 6, 1 2 3 4 5 6. So I multiply it by 6 because there are 6 equilateral triangles, and then I multiply it by height, right? And here in this diagram you can see that I have mentioned that the total height is C, right? I have considered this with symbol C, like from here till here, this distance, right? This one I have taken it as C, right? So if I multiply this area multiply by this height, so I will get the volume, right? So volume of the cell or total cube is equal to and yeah, the area of the equilateral triangle has a formula under root 3 by 4 a square, right? This is an equilateral triangle and this is the formula for it. So I have written here the formula, then multiply by 6 and multiply by total height. So total height from here till here, it's C. So that's how I will get the volume of the cell, right? Now let put these both values in the packing factor formula. So I will get what I will get. So here it's 4 by 3 pi r cube, right? And here also I have written 4 by 3 pi r cube and multiply by 6. Here also I have multiply it with 6 and divide by the volume of the cell. So it is under root 3 by 4 a square, right? Multiply by 6 and multiply by C. Now here this 6 is cancelled out with this one, right? And this 3 will come down over here and this 4 will move over here, right? So if this 4 move over here, so this 4 and this 4, it will make 16, right? And then pi r cube. So here I have written pi and this is r cube, right? And if this 3 move here, so it will multiply with this under root 3. So under root 3 multiply 3 and here I have left with a square and C, and here I have written a square and C, right? Now let me make one thing more clear here, that the distance that we have taken here from this point till this point is 2r, right? A is equal to 2r. So how this comes out to be 2r? If we see this diagram, right? So it is the actually this distance is it is the distance from the center of this atom till the center of this atom, right? So from here till here it will be r, and then from this center till this center it will be again r. So r plus r, it comes out to be 2r, and I have taken it equal to a. So this from this point till this point it is a, then similarly from this to this point it is 2r, similarly till this point between these two, and then so on. So all these distance equals to a, right? So a is equal to 2r, remember it. So here we can see that I have taken a is equal to 2r, and if I want to find the r, so 2 will come down and r will be equal to a by 2. So here instead of r I have put this value, right? A by 2. So a by 2 power cube, because here is power 3, divided by under root 3 multiply under root 3 multiply a square multiply by c. So it will become 4, and this 4 it will not become 4. The power 2 power 3 equals to 8, right? 2 power 3 equal to 8. 2 2s are 4 and 4 2s are 8, right? And this is 303 a square and c, and here it's 16 pi a cube. So this 8 will be cancelled out with this 16, and here we will left with the 2 and pi a cube, right? Here is 3, so a cube, and this 3 will be cancelled out with this square, right? So if we see here, so as I told you, this 3 will be cancelled out with this a square, so here we will left with 2 pi a square, 2 pi a, so 2 pi, right, and a, right? And here down we are left with 303 and c, so 303 and c, and this is equal to the packing factor. If I shortly write it as p dot f, right, packing factor. So I have named this equation as equation star, and here what we have to do, that we know 2 pi 300, this will give some value, numeric value, right? So what we have to do, that we have now to find the a by c ratio, and when we find this a by c ratio, so then we will just plug in the values in this equation, and we will get the packing factor for the HCP, right? So now let's move further. So this blue triangle, right here, you can see this blue triangle and this red one also. So let me first make it clear over here that how these triangles I have taken. So remember one thing, that as I have told you, that from this point till this point, this distance is c, right? Till, if I say from this total distance is c, and if I take the distance from the center of this blue atom till the lower atom, so obviously it will be c divided by 2, right? Like if I draw it here, so from here till here it's c divided by 2, right? This distance, right? And this total is c, right? I am talking about this blue one because it is in the center of this structure. So the first triangle that I have made over there, that it is from here till you can see that this line is coming to the center of this equilateral triangle, right? Like if I see if we see it from here, from top, so we will see this kind of triangle over here. I am talking about this triangle, right? This one. So the line, this green line that I have drawn, is actually touching this equilateral triangle at its mid, right here, right? And then what I have did, that I have matched this over here, right? So here, and then this one, right? So this is the first triangle that you will see there, right? I will show you. And there I have made another triangle. So if you see again from top, so it look like that. Let me give it another color. So if I see it from top, so this equilateral triangle will look like that, right? So the second triangle that I have made is this one, right? Something like this, right? It is between these two, right? So this is the distance r. Why it is r? Because it is from here till here, right? So its distance is r, and then this one, right? And then this one, like that. From top you can see, so you will see something like that, right? Now if we move to that diagram, so here I told you that this distance is c by 2, right? This because it is touching the center of this equilateral triangle, this perpendicular distance of the blue triangle, right? And the red one I have also showed there, that from top this is the triangle that we have made if you see from top, right? And the distance from here till here, it's a. How I have taken it a, let me show you here. Like these in actual, like it's a 2D model, but if we see in 3D model, so these atoms are touching each other, and that line, this line, if I show you this line, how this line is made, so it was something like this, right? So from here to here it was r, and from here till here it was r, right? So before we have taken it a equals to 2 r, right? So that's why I have taken this distance as a, right? And this I have named this triangle as zxa. And if I see this red one from top, so it is from the center of this atom till the here, right? And then till the here we have discussed before that here we can see an equilateral triangle is made, right? How this equilateral triangle is made, we have already studied this in lecture 7, right? So it is going till its midpoint, and then I have joined it here. Now one another thing to mention here, this angle, right? That what is this angle? So as we know that this is a equilateral triangle, so the wait this let me take this red one. Okay, so this is a equilateral triangle, right? It doesn't look like that, but if you see clearly, let me show. 1 minute, let me show here. So this is equilateral triangles, right? So we know that in equilateral triangle, this triangle, this will be 60 degree, right? This angle will be 60 degree, same this angle will be 60 degree, and this angle will also be 60 degree. But the triangle that I have made over there, that was having a color of red, so it was passing from this center till here, and then this. So we can see that this line is passing through the center of this angle, so this angle will be 30. The angle, this area, the angle that is made with x with the axis, right? So this will be 30 and this will be 30, so combined it will make 60, right? So if we see there, so this angle is this angle is 60, right? Oh sorry, 30. So now if I apply the, first of all let's check for this, let's solve this red triangle. So if I apply cosine law, so cos 30, right? I have told you that this angle is 30, that how this angle comes out to be 30, and cos 30 is equal to base by hypotenuse. So here base is r, or we can say ya, but I have told you that it is equal to r, so I have put here r, and this perpendicular sorry, hypotenuse, it's xa, so I have written here xa. Now if I move xa over there, and cos 30 will come down, right? So if I cos 30. So cos 30, right? So it comes out to be under root 3 by 2, right? Under root 3 by 2, we can see here under root 3 by 2. And I have also, oh sorry, and I have plug in here under root 3 by 2, right? So now this distance, the XA, like this hypotenuse, this one, right, from here till here, so it comes out to be 2r divided by under root 3, right? This hypotenuse XA comes out to be 2r divided by under root 3. And so now if I take this blue one triangle, right, ZXA, right, I have written over here triangle ZXA. And now if I apply Pythagoras theorem, so it is hypotenuse square plus perpendicular square plus base square, right? So ZA square, right, it is the hypotenuse, and it's base square, right? It's the base XA square plus ZX square, right? It's the perpendicular distance. So now if I bring this ZX, if I move this XA over here, so it will be ZX square equals to ZA square, right? This one, and this will move there, so it will become minus, so XA square, right? So if I plug in the values, so ZX, so I have told you from here till here it's C by 2, right? I have make it clear that how it comes out to be C by 2, right? And ZA square, I have also told you that it is the, if we see in this diagram, so it's actually the from here till here, right? So it's 2r, it's A. In 2D model it look like that, but in 3D model these two atoms are touching each other, so it's is A, right? A square. And now if I talk about this hypotenuse, so we already XA, so if I move here, so XA was 2r divided by under root 3, so here I have written it 2r under root 3 whole square, right? So if I take square, so it will become C square divided by 4, and it's A square. Now it comes out to be A square of 2 become 4, and r square divided by 3, right? Now what we have to do that we actually want to find the A by C ratio, and in order to find the A by C ratio, what we have to do that we have to eliminate this term r, right? So from previous discussion, now we know that r is equal to A by 2. A is equal to 2r, so r will become A by 2. So instead of r, I will plug in the A by 2. So if I plug in A by 2, so it will become A square, right? Because it is square over there, so it will become A square divided by 4. So this 4 will cancel out with this 4. So here we will just left with A square by 3, right? Here it is written A square by 3, and C square by 4 equal to A square, right? Now moving further, if I now take the LCM, so this 3 will move there, it will multiply with this A square, so it will become C square by 4 equal to 3A square minus A square by 3, right? So if I subtract it, so it will comes out to be 2A square divided by 3. Now move the 3 over there, right, and 2 over here, right, and C will also come there, right? C will also, C will come here, right? So it will be A square by C square ratio equals to 3 by 4 multiply 2. So A square by C square is equal to 3 by 8. It comes out to be 3 by 8. And if I take the under root over here, and similarly I take under root over here, so this will cancel out, right? These squares will be cancelled out with this one, this under root, so A by C, and this will comes out to be 3 by 8. So now A by C ratio is under root 3 by 8, right? Now we will just plug in this value into a packing factor equation star, right? Let me show you what was that. So equation star is 2 pi by 3 under root 3 and a by c, and here we find that a by c is under root 3 by 8, right? So simply what we have to do, that we will just simply plug in the values, right? And instead of a by c, I will put under root 3 by 8. Now let's plug in these values in calculator in order to check what will be the answer. So 2 let me bring it here. So 2 pi, right, divided by 3 under root 3, right, and multiply by whole under root 3 by 8. So here we go. So the packing factor of the HCP comes out to be 0.74, right? So that's it for today, and the next lecture will be the last lecture of this chapter. So see you in next video, and thanks for watching.